Okay, now an important reason to sketch graphs or use graphs is to determine how many solutions or roots there are to particular equations. So what we want to do, we want to find out how many solutions and then finally where the solutions to this equation lies. So to do that, what we're asked to do, we are asked to sketch both of these as their individual solution, as their individual graphs. So we're asked to sketch y equals sine of x and y equals 1 minus 2x. So to do that, we've got, there's our sine of x, and then we'll have 1 minus 2x, which will go through there. So here we are at 0, and here we are at 1 over 2. So that's something that we've got there. So we're at that's our points. That's what we're working with. So basically, what we'll be asked to do is to find out how many solutions there are. So in this case, we can see that we've only got one solution. As well as that, we'll be asked to find an interval over which the solution lies. Now we can tell from this that the solution lies between 0 and 1 over 2. So our solution is somewhere between there. So based on that, what we then do, we need to find out, we need to be able to demonstrate that happens. So it's kind of like what we did in term 1 where we started bisecting. Now, what we need to do is, firstly, we've got to write this as one equation. So we take this and let it equal 0. So basically what we're doing is we're saying we'll end up with sine of x minus, plus 2x minus 1. So that's what we're dealing with there. And we say, well, that's our f of x. Actually, let's see if let me move this over. The whole thing, that's okay. We're saying that is our f of x. Now what we're going to do, we're going to substitute our two x values. We're going to substitute 0 and a half. So we're going to say f of 0, we end up with sine of 0 plus 2 times 0 minus 1. So we end up with negative 1. And we're going to substitute a half. So we're going to say we're going to have sine of 1 over 2 plus 2 1 over 2 minus 1. Now, so we'll end up with sine of a half plus 1 minus 1. We end up with an answer which is positive. So here our answer is negative, here our answer is positive. So because we alternate between negative and positive, we've proven that a root exists between 0 and a half. So what we then do is we continue to bisect, and I'll show you how to do this with CAS in order for us to find an approximation to where our solution lies.